Hello! In this video, we'll talk about operands stored in memory. So, most interesting programs have too much data to fit in only 32 registers, and will store the additional data kept in memory. The memory is much larger, but it can be slow. For example, an embedded system may have kilobytes or megabytes of memory, and a laptop or PC or a mobile device will have gigabytes of memory. So we'll keep the most common variables in registers, and then we'll store the less commonly used ones in the larger but slower memory. First, we'll discuss word addressable memory, in which we keep each memory location holding one word. Then we'll adapt to byte addressable memory, which most microprocessors, including RISC-V, are really byte addressable, and we'll explore the difference. So in a word addressable memory, each 32-bit word of data is stored at a unique address. So word address 0 could have this word A, B, C, D, E, F, 7, 8. Word address 1 might have this data value F2, F1, AC, 0, 7. Regular instructions can't use memory directly as an operand. For instance, add and subtract only work on registers, not on memory. So instead we need a new type of instruction called a load that reads data from memory into a register. So the load word instruction will read a value from a memory location and place it into a register. An example of that would be load word T1 gets 5 parentheses S0. And the first argument is the destination register to put the result in, and the second part is an offset relative to a base register. So in this case, the offset is 5 relative to the base register of S0, and the answer will go into T1. So for example, let's say we want to read a word from memory address 1 into register S3. We can write load word S3 gets 1 parentheses 0. The base address register is 0, which just has the value 0. We add an offset of 1, that gives us memory address 1. We look at that address and we see stored in memory is F2, F1, AC07. We read that out and we put it into S3. Similarly, there's a store word instruction that takes a value from a register and puts it into memory. So for example, if we wanted to store the value from register T4 into memory address 3, we could take the base address of 0, add an offset of 3, and store T4 into that. Supposing T4 contained the value feed cabe, then after we run the instruction, memory location will 3 will have feed cab. Now in reality, most computers use byte addressable memory. So each data byte has its own unique address. And we introduce load instructions that can access a byte as well as just a word. So a word in our processor is 32 bits, so that's 4 bytes long. So each word address is a multiple of 4 bytes. And so word 0 is still at address 0, but word 1 is really at address 4, not 1. Word 2 at 8, word 3 at C, word 4 at 10 in hexadecimal. And within each of those words, there are 4 byte addresses for the bytes within the word. So if we want to read a byte addressable memory, the address of the memory word now needs to be multiplied by 4. So if we're interested in the second word, that's address 8 in memory. If we're interested in the 10th word, that's address 40 in memory, or in hexadecimal 40 is 0x28. So it's important to remember RISC-V is byte addressed, not word addressed. Let's do an example. Suppose we wanted to read the second word again. Now it's load word S3 gets 8 parentheses 0. This is the correct code on RISC-V. and we would read the value at word address 8 and put it into S3. Similarly, if we want to write an address, we could do a store word T7 into address 0x10 parentheses 0. 0x10 is word hex 10. That's address hex 10, which is the fourth word in memory. And we would put in the value from T7.